Welcome back to the channel. Today we're doing one of the craziest experiments ever. First, we're freezing an iPhone for 24 hours to see if it can survive extreme cold. And then we're putting the same phone under a powerful hydraulic machine to test its strength under massive pressure. From freezing to crushing, this is the ultimate experiment you don't want to miss. Let's begin the test. An experiment was done in which an iPhone was first placed in a tub of water and then, while still wet, kept in a freezer for 24 hours. Even though the phone was completely surrounded by ice and all its ports, buttons, and speakers were frozen solid, it surprisingly managed to hold its internal components together. When it was taken out of the freezer, the ice slowly began to melt, and for a short time the screen looked foggy, the touch was slightly slow, and the speaker produced a faint distorted sound. When a glowing metal ball heated to around 1,000 degrees Celsius was placed on a small jelly bed, the reaction was surprisingly intense and dramatic. The instant the scorching ball touched the soft, wobbly jelly surface, a sharp sizzling sound filled the air as thin streams of steam rose upward. The extreme heat instantly melted the top layer of the jelly, turning it into a bubbling pool of sticky liquid. As the ball continued to sink deeper, the jelly around it darkened and began to caramelize, forming burnt patches where the heat was strongest. Tiny cracks appeared across the jelly bed because of the sudden temperature shock, and the once perfectly shaped jelly started trembling and losing its structure. Within moments, when an oversized load of clothes is pushed into the shirting machine, the system reacts with noticeable strain. As the heavy bundle enters the rotating chamber, the machine makes a deep humming sound, indicating that it is working harder than usual to manage the weight. The rollers and belts attempt to pull, lift, and separate the thick pile of shirts, but the extra volume causes the fabrics to twist together instead of spreading out smoothly. Inside the chamber, sensors detect inconsistent motion, triggering sudden vibrations that shake the entire unit. The airflow vents struggle to maintain balance, and the machine's internal fans run at maximum speed to prevent overheating. Because of the excessive load, some shirts fail to pass evenly through the pressing section, causing temporary jams that slow the cycle. The machine eventually processes the load, but the final result shows clear signs of stress. Some shirts come out wrinkled, slightly stretched, or not properly aligned. A hydraulic machine operates with incredible power, using high-pressure fluid to create a controlled but massive amount of force, and watching it work is both fascinating and intimidating. When an object is placed beneath the press, the upper plate slowly descends with a steady, unstoppable motion, driven by the pressure built inside the system cylinders. The elephant toothpaste experiment is one of the most exciting and visually dramatic science reactions, creating a huge foamy eruption that looks like toothpaste being squeezed out of a giant tube. When hydrogen peroxide, dish soap, and food coloring are mixed in a container, nothing happens at first, but the real magic begins the moment potassium iodide or yeast is added as a catalyst. Instantly, the hydrogen peroxide breaks down into water and oxygen gas. And because the dish soap is present, the oxygen gets trapped inside thousands of tiny bubbles. Within seconds, a thick, warm column of colorful foam shoots upward with surprising force, spilling out of the container and spreading across the table like lava.